Hi everyone, just wanted to take a moment to continue on with our discussion of proofs. Today what we're going to be looking at is algebraic proofs, which is kind of our next logical step, right? So we started with our paragraph proofs, which include a lot of the words that you're a little bit more familiar with and some of the writing conventions of English. And now what we're going to do is instead of using words, we are going to be using numerical operations. There's still things that you're familiar with and comfortable with solving, um, but ultimately, we're going to kind of build that into the structure of what we're going to have our geometric proofs kind of look like. So we started over with our words to describe things. Now we're moving into algebraic proofs to get some of the structure down. And then we are going to later on kind of continue into the full-blown geometric proofs. All right. So there's a couple pieces of information that we do need to make sure that we are familiar with and acquainted with. And a lot of these are things that you're probably aware of or know of, but just want to make sure that we're clear on. So there's obviously, the commutative property, associative property, distributive property, the identities, inverse properties. These are all things that you don't need to prove ahead of time. You can just utilize them. In particular, this table over here proves to be really useful for us when we're actually trying to solve things using algebraic proofs, right? The addition property where you can just add something to both sides, subtraction, subtract something from both sides, multiplication, division. These are kind of the formal properties that we would actually be using when we're going through different types of algebraic proofs. But ultimately, this is kind of the justification and the step-by-step reasoning through what you're doing. So these can be a little bit tedious to start with, but ultimately, once you get used to what it is that I'm having you write, we can look through and continue on with them. So let's just make sure we're familiar with these properties themselves, right? So if we're looking at this first one, we're saying if A is equal to 4.75 and 4.75 is equal to B, then A equals B. Well, that's transitive, right? If X equals Y, then X plus 8 equals Y plus 8. Well, that's just the addition. Add property. I'm not going to make you write the addition property of equality every time. You can just write addition, but ultimately that's the formal full name. 5 times, in parentheses, 12 plus 19 is equal to 5 times 12 plus 5 times 19, right? Distributive. These are all things you know, but just want to make sure that we're clear. If X is equal to 5, then X can be replaced with 5 in any equation or expression. That's substitution. Substitution, I'm usually just going to write sub. A lot of times, substitution sometimes gets incorrectly used in terms of how we're writing it. You just need to be careful with it. Really, it's just when you're taking it and you have it X equals something, and then you're replacing X with that number. All right. So if X equals Y, 8X equals 8Y. That's just multiplication. All right. This one is one that many people forget. If X equals 23.45, then 23.5 is equal to X. Let's just make sure that we're clear on that one. If you go back here, all right, reflexive is A equals A, so that'd be 4.5 equals 4.5. Symmetric would be X equals 4.5, and then 4.5 equals X. All right, so that one's symmetric. Okay. Symmetric. Okay. This one we have 5x equals 7, then x equals 7/5. That's division. 12, x minus 3 equals 9, subtraction, right? Okay, so these are, I need to be clear if I'm going to have both subtraction and substitution. Okay, subtract. Okay, so these are the types of reasonings that you're going to be using in your algebraic proofs. These in blue here, these are going to be your justifications. These are going to be your reasons, right? you would have something like as a statement, something like this. However, the reason then is distributed. Okay, so let's look at what actually is an algebraic proof. So really, it's just formally writing the information, right? So all we're doing is exactly what you would have been doing at any other given time in terms of solving an algebraic equation, but now I'm making you write all the steps down, right? So if you were to look at this in terms of the algebraic steps, we're given that piece of information to start. Our starting given in this case is now like the initial equation that you're told. Then when you distribute, you can use the distributive property. Let's see, substitution, we're really combining like terms. You could write combining like terms, they call it substitution in there. Adding 2 to both sides. -2 plus 2, you can substitute that with 0. So what they're saying, by the way, when they're saying substitution, is 6x plus 2 can be substituted with 8x. That's fine if you just say combined like terms. I get what you mean by that. But ultimately, that's why they're using substitution. And then division, and then substitution again. Okay? So that's really all we're doing in an algebraic proof. So then, if we were to formally put this together into a proof, what we would do is, instead of writing it out this way, where we're just kind of listing things, we would formally have it in this setup called the two-column proof, where we're given this equation, and we're proving that x is equal to -2. So all we're doing is you're doing the regular algebraic steps you would have always done, but now you're providing justification for it. All right? So that's what's given. We use the distributive property. By the way, you don't always have to show like all the intricate steps. See here, like they did the distributive. You didn't need to write 5 times x plus 2 times 5. You didn't need to do that. You could have. You can move past that. Then if you have the next step, we would add 3x to both sides, subtract the 10, then divide, right? So that's all we are doing at this point in terms of writing proofs. It's all the content that you know, you understand it, and it shouldn't be anything crazy. It's just a matter of formally doing it. All right? So, for example, if I were to give you something like this, we could go through it and fill in the blanks, right? So remember, the first thing that we are told is this is what we are given, okay? So you're always going to have as your first step a statement, a reason of given, right? What did we do here? Oh, there's a little line there. I almost missed that. Okay, so what did we do? We multiplied everything by 2, right? So we multiplied everything by 2. That's the multiplicative property of equality. Let's see. Well, what were they calling that before? They were calling that substitution. Okay, right? They were just calling it simplifying the substitution. Now we are doing the subtraction property. Okay. And so that ultimately would be is equal to 12, again, substitution. 12 divided by 4 would be the division property. And then ultimately you get x is equal to 3. Okay. Now, if you wanted to, for simplicity, what you could have just ultimately done is, you could have gone right from here to here and just said multiplication, from here to here and said subtraction, from here to here and just said division. But if you want to be more specific, you can include the substitution components. But I know what you're doing when you're doing those. Okay. Oh, I almost forgot. QED, quod erat demonstrandum, that which was to be proven, or that which was to be shown, or if you would rather, little box, you can fill it in if you want. I like the QED. It makes you feel really smart when you say it, but it's kind of your own personal preference. All right, so let's do it a little bit more. Let's be a little bit more complicated when we're doing something like this, okay? So what are we starting off with? Again, what we are given. Now, how did we do this to go from here to here? Well, we use the distributive property. Okay, we use the distributive property. Now let's see, what did we do? Well, we combined, right? So whenever we were combining, we just call that substitution. All right. We're adding 15 to both sides, so we're going to use the additive property. Okay, the additive property of equality. Then what are we doing? Well, when we are adding, we're substituting again. All right, so now what are we doing to both sides? Well, we're subtracting the 8n, as you can see. So we are using the subtraction property of equality. We are then substituting again. You can see a pattern here. We're doing something, substituting, doing something, substituting. Then we are using the division property. And I'll give you a hint, last one, substituting. Okay, and then I'm all done. So ultimately, these are relatively straightforward, just once you have some of these properties down. I'm going to leave the next one in the slideshow to you to try. Ultimately, what it is it's kind of doing one from scratch. But again, what are we going to do, right? You're just going to do the type of concepts that you do every single time. We're adding things together. We know what they are. So you're just going to start with what you're given. Do the math that you were always going to do. And then formally write it as a proof. Okay? So that is ultimately what an algebraic proof is. Please let me know if you have any questions. Have a good night.